Yes, welcome back to the next session of rehabilitation and retrofitting of structures course. In the last session, we were discussing regarding the various techniques for repair in order to resist the damage on the concrete structures. So in that we have discussed the various techniques like rust eliminators, then polymer based coatings, dry pack mortars and so on. So today we will look into some more techniques for repair, okay, and which will be all these, as I mentioned, all these techniques were used specially, okay, meant for a damage, specially meant for a damage. That means each repair technique whatever we are going to discuss or what we are going to learn will be, okay, ideal for one particular damage. Okay, that means each particular whatever the solution or a technique may not be suitable for all the damages. Okay, so for particular damage one material will be ideal. Is it clear? Fine. So let us look into this. Today, next one is vacuum concrete. Next one is vacuum concrete. Okay, so let us see what is a vacuum concrete. Vacuum concrete is a type of a concrete in which the excess water will be removed for improving the strength of a concrete. The water is removed by, how exactly we are going to remove? By providing the vacuum mats on the surface of the concrete, and those vacuum mats will be connected to the vacuum pump. Okay, so that is what, okay, that is what I can say a vacuum concrete. Okay, so vacuum concrete is a type of a concrete in which the excess water will be removed. Okay, those excess water will be removed. Why? Because by reducing the water cement ratio you can enhance the strength of a concrete. You can enhance the strength of a concrete. So that is the advantage you are going to get. Not only that, you can improve the durability properties also. That's why they are going to reduce the water cement ratio, okay, or water content. So those water content can be reduced or water can be reduced using a device called vacuum mats, and those vacuum mats will be connected to the pump. Okay, you can see that this is a typical okay, pictorial view of how exactly it will be done. Okay, this is what a vacuum mat, okay, and this vacuum mat will be connected to the pump, okay, and this is the vacuum pump, okay, and this is what, okay, water separator. So like this they are going to, okay, you can see this is a concrete surface, a sealant, okay, and the vacuum mat already been provided. So from this, okay, the concrete, okay, they are going to evacuate the water, and this water will be collected in the water container. Okay, so all the water used in mixing concrete is not required for hydration. So whatever the water we are using, okay, whatever the water we are using, okay, for what I can say hydration purpose, okay, the technocrats as by research it says that, okay, whatever the water cement ratio or water content may not be needed for hydration, because you already know that the curing process or whatever the water we are going to add will be for the hydration purpose. But whatever the water I am going to add, so all those water will not be required for hydration. So hence, okay, as the water cement ratio law says that 0.3 or okay, nowadays they are reducing the water cement ratio to level of 0.25 to 0.3. 0.25 to 0.3. So that is the extent of water cement ratio they are reducing. So instead of adding 0.45, 0.5 something like that, okay, it is simply what I can say reducing the strength of concrete. So that's why you can manipulate by reducing the water cement ratios. Okay, and in this particular vacuum concrete preferably, okay, whatever the water have been added, okay, those water they are going to remove from the, okay, the concrete surface, okay, so that the concrete will obtain sufficient strength. So that's what the process, okay. So that's what the same explanation which I have been doing, okay. So if you want a good workability which will be very pace for the formwork, okay, those fresh concrete contain some water filled channels. So okay, by application of this vacuum we can remove those water so that you can get a sufficient strength in the concrete. So that's what I have been written. Next, what are all the advantages you are going to get from this vacuum concrete? So as I stated, the final strength of a concrete is increased to about 25%. So compared to the, okay, when you are going to leave the water cement ratio as it is without any removing those water, compared to that concrete, okay, the concrete in which the excess water has been removed, so that particular concrete will attain a strength more than, okay, 25% or increase by 25%. Okay, sufficient decrease in permeability of concrete is obtained. This is a very important. Okay, so that means the concrete will become impermeable by removing the water cement ratio. It will try to fill up, okay, or it will not develop any capillary voids, all those things. Okay, so it will be advantage for a concrete also, so that in future no villains can enter inside the concrete to damage the interior properties of a concrete. Next, vacuum concrete stiffens very rapidly so that formworks can be removed within 30 minutes. So this is the advantage. We can remove the formwork very early. Okay, even on columns 20 feet high. That means even on the columns. This is of considerable economic value, particularly in a precast factory. Preferably, this vacuum concrete technique we can go ahead in the, preferably in the case of a precast factory product. So when you are going to manufacture any products in a precast factory, at there, okay, you can go ahead with these technologies. The bond strength of vacuum concrete is about 20% high. So see, the bond strength is a very essential thing. Okay, so this is also can be improved. The density of vacuum concrete is higher, no need to worry. Okay, because why the density will be higher? Because you have completely removed the water content. So there no capillary voids will be developed inside the concrete. So if there is no capillary voids inside the concrete, that means automatically there will be increase in strength of a concrete. Or also I can say density is more. The surface of a vacuum concrete is entirely free from pitting and the uppermost 1/16 inch is highly resistant to abrasion. So almost I can say up to 1/16 depth, okay, this concrete is able to resist any abrasion effects. Next, these characteristics are of special importance in the construction of concrete structure, which are to be in contact with flowing water at a high velocity. Okay. So these characteristics are special importance in concrete structures which are to be in contact. That means when you are going to design this particular vacuum concrete for any particular surface, okay, if there is any flow of water, we need to be very cautious because you cannot, this concrete may not perform better in that particular location. Next, it bonds well to the old concrete and can therefore be used for resurfacing road slabs and other repair works. So especially it bonds well, okay, we can go ahead with these repair works, especially in the rigid pavements. So these are all the advantages you are going to get from this, what I can say, the concrete, the vacuum concrete. Okay, so hope the concept has been clear. Okay, so preferably this vacuum concrete is preferred once again majorly in what I can say repair works, mainly in the rigid pavements. Okay, and also I can say the parking lots. Okay, when there is a parking lot, okay, damage in the parking lots, okay, at that particular instance we can go with these vacuum concrete techniques. So next we will come on to the very important technique of repair predominantly used to heal the cracks. The very important techniques predominantly used to heal the cracks is epoxy injection. So this is the predominantly used technique to heal the cracks. Okay, what is that? Epoxy injection is an economical method of repairing non-moving cracks. So please note the point. Please note the point. Non-moving cracks or non-active cracks in concrete wall, slab, column and piers, and is capable of restoring the concrete to its pre-cracked strength. Okay, that means whatever the inactive cracks that has been formed on the concrete structures, so those concrete cracks can be healed with the help of epoxy injections. Okay. Next, the two basic types of resin and injection techniques are used to repair concrete are epoxy resin and polyurethane resin. So these are the two polymer based, I can say polymer based resins, okay, are typically used resins. Okay, that will be used as a crack repairing material. That is epoxy resin and polyurethane resin. So these are the two polymer material or resins we are going to use in order to heal that cracks in the concrete structure. The injection of epoxies under pressure may be used to bond the cracks having a greater than or equal to 0.05 millimeter opening. So this is a predominant, this is, I can say, very advantage thing. Even a crack width of 0.05, you just imagine, you cannot see that properly, the crack, through the naked eye. So that crack can be very easily healed by the help of a epoxy injection. So that is the advantage using the epoxy injection. This method is not applicable if the crack is active. Please note the point. Note the point. Epoxy mortar, epoxy crack concrete I was using for active cracks. I will repeat. Epoxy mortar, epoxy concrete I will be using for active cracks. Okay. Epoxy injection will be using for inactive cracks or not active cracks, or I can say non-structural cracks. Okay. So that's what is not applicable if the crack is active. The cracks are large in number or when the water leakage cannot be controlled. That's why under these conditions this epoxy injection may not play the role. Okay. Next, epoxy injection is commonly used to restore the pre-cracking condition of the member, without increasing its strength. So that's what I have been told. This epoxy injection will act like a crack healer. By providing epoxy injection, you cannot increase the strength of a concrete. Please note this point. Typically this epoxy injection will be used in order to heal the inactive cracks. Coming to the steps, how exactly this epoxy injection will be done. Step number 1, preparation of the surface. So before applying the epoxy injection, the preliminary step is to prepare the surface. So let us see how exactly we are going to prepare. The contaminated cracks are cleaned by removing all the oil, if there is any oil, grease, dirt, the fine particles, that is left out inside the crack. So that complete, things need to be removed. So that is the first step. Why it need to be removed? Because whatever the epoxy injection which I am going to provide inside the crack bed, so those epoxy injections will not properly get bond to the concrete. So in order to overcome this problem, you need to remove all the dirt materials. Next, the contaminant should be preferably removed by flushing the surface with water or a solvent. So whatever the contaminants are there, you can remove also by water, or I can use a air blower also. The solvents is then blown. That's what, using a compressed air or by air. You can use compressed air or air blower or water, to remove the dirt material or grease or whatever the material. The surface crack should be sealed to keep the epoxy from leaking out before it has been cured or jet. So I think I have been show you this method in the case of the surface mounted reinforcement. So there I have been showed they are going to groove that, they are going to cut the concrete surface, on above that they are going to lay the tape. So here also the same thing, they are going to lay the tape on the surface of a crack and they are going to remove that crack, so that epoxy should not come out excess. So that is the technique they are going to use, so that you can do accurately. Next, a surface can be sealed by brushing of an epoxy along the surface of cracks and allow it to get hardened. If extremely high injection pressures are needed, the cracks should be routed to depth of about 12 mm and width about 20 mm in a V shape. If you want to fill up the crack, it is a very important thing we need to know while repairing the cracks. First, while inspecting, what is the depth of the crack we need to get to know. Nowadays, various techniques are there. I think in non-destructive techniques have been highlighted. Ultrasonic pulse velocity method, not only it can say find out the quality of a concrete, also it will determine the depth of the crack. So what is the depth of the crack that has been come across in the surface of a concrete? So that also can be identified. Why? Because those depth, whatever the epoxy injection I am going to inject inside the crack, so that epoxy injection should reach that to a particular entire depth of the cracks. So that is very important. So that's what. So it is predominantly done by cutting V-shaped groove, okay, a width of 12 mm or 20 mm, okay, and to a depth of 12 mm, okay. So this is regarding preparation of surface. Next is installation of entry ports. Entry port. So it is something like a, okay, what I can say, the syringe which we are going to fix it to the cracks. I will show you a small video how exactly the epoxy injections will be done. The same preparation, whatever I have been explaining theoretically, I will showcase you in the video. The entry port or nipple is an opening to allow. That means that 0.05 mm crack, we cannot inject directly, okay, something as it is. We cannot pour it. So what they have been measured here, what they have come up with a device called entry ports or nipple. So those nipples or whatever the entry ports, we need to fix up to those particular width, so that that will be properly fixed. Okay, through that nipple or entry ports I am going to inject that epoxy injection, so that these epoxy injections will go to the entire surface. So that is what the thing we are going to do. So that's what the injection of adhesive directly into the crack without leaking. The spacing of the injection ports depends upon the number of factors such as, that's what, depth of the crack, width of, that's what. That entry ports having a different dimension. So depending upon the width, depth of the crack, we need to provide the entry ports. So depending upon depth of the crack, width or crack and its variation with depth, viscosity of epoxy, injection pressure, etc. and choice must be based on experience. So based upon this experience, okay, we need to accommodate these entry ports to yield. That's what. Whatever the depth of crack, for example, if it is 15 mm depth crack and you have been provided epoxy injection to a depth of 7 to 8 mm, the remaining left out space will be waste. Okay, that means you are not provided the technique of repair of epoxy injection properly. That's why we need to properly investigate what is the depth of the crack. Okay, we need to make a proper groove. Okay, then we need to insert that entry ports depending upon the width, the depth, okay, and also what is the viscosity we need to inject that epoxy. All those things will come into the picture. Next, mixing of epoxy. The mixing can be done either by batch or continuous method. What is that? In batch mixing, the adhesive components are pre-mixed in specified proportion with a mechanical stirrer in an amount that can be used prior to the commencement of the curing. So that is called batch mixing. Continuous mixing means two liquid adhesive components passes through metering and driving pumps prior to passing through an automatic mixing gate. So that means in the batching mixing we are going to do the pre-mixing, and in coming to the continuous mixing we are going to continuously do the process. So this is regarding injection of epoxy. That is the next step. Okay, that is we have prepared the epoxy injection. Now we need to inject the epoxy to the cracks. So injection can be done. The injection equipment consists of small reservoir or funnel attached to the length of a flexible tubbing so as to provide a gravity head. Okay, for small quantity of repair material, small handheld guns are usually most economical. That depends upon the depth of the crack. Okay, they can maintain a steady pressure which reduces the change of damage to the surface seal. Okay, so that is the next step. Next, removal of the surface seal. That is what is important. After putting all this epoxy injection, we need to remove it. How exactly we are going to do this? After the injected epoxy has occurred, the surface seal may be removed by grinding or other means as appropriate. Fittings and holes at the entry ports should be painted with a epoxy patching compound so that you can clearly know it. So this is regarding your epoxy injection. So now I am going to show you a small video so that you can clearly know how exactly this epoxy will be done. So please look into this video so that whatever the theoretically have been explained, okay, so those things you can see visually. So first I will going to show you the vacuum concrete so that you can see how this vacuum concreting is done. You can see this is the technology they are going to use for a vacuum concrete. You can see here, okay, they have been provide the vacuum mat. So this is what I have been told, vacuum mat, okay, and this is what a pump they have been attached, okay, and this is what a pump, okay, and they are removing all these things. See here, on other side they are removing the excess water. At one side they are collecting the water using the pipe, and on the other side they are removing the water. So this is what the technology they are going to use. This you can see here. See, this is what a mat they have been provided, okay, in order to remove the water. So this is what I have been told, vacuum mat, and they are removing the vacuum mat. And later on they are going to use a screed vibrator. Why? Because okay, you can see the unevenness on the concrete surface. So those unevenness they are going to clear off by this vibrator. Okay. At one end they have been removed, and the other end they have been, okay, removing the water content. So whatever the water has been collected, so those things will be left out. And later on they are finishing the concrete surface. So this is what the way of vacuum concreting they are going to do. Okay, next, epoxy resin. I am going to show you this two videos. One is the old method, another one is the new method. You can see here, okay, how exactly the techniques. See, this is what entry ports, okay, this is what I have been told, entry ports, okay, and this is what the various adhesives you can see, and this is what you can see the crack formation. Okay, earlier they were using, okay, you can see here they use adhesive, and this is what entry port, and to that entry port, okay, see they are cleaning with a wire brush. So this is what a crack that has been formed. Okay, to this they have been cleaning, okay, they have been cleaning completely. So whatever the dirt materials are there, they are cleaning completely, and later on they are going to add this as a bonding agent. Okay, so this is what a bonding agent initially they are going to apply, okay, so that they can clearly fix up the entry ports. You can see over there, okay, they have been completely filling those, okay, the gaps or whatever the crack that has been formed with the adhesives. Okay, you can see here they are going to lay this particular adhesives, and later on you can see this is what a entry port or a nipple, which I used to say. Through this entry port or nipple only I am going to inject the epoxy. So they have been marked over there, okay, and they are going to fix those entry ports to the wall or whatever the crack surface you can see here. Okay, this is what a opening, okay, this is what a opening, okay. So is clearly say, okay, how exactly that fixture is going to fix, so that he has been explaining. Next, it is going to get hardened for some time. Next, okay, notice, allow miracle bond to completely cure before starting. That's what. Allow that whatever the bond that has been applied, okay, to cure it. So whatever the paste they have been applied, so those paste need to get cured. Okay, and always try to wear eyewear, because it is okay, very contagious. It may spray to the eye. Okay. Next, you can see here, this is one method. This is something like a gun, handheld gun. This is a handheld gun. Okay. Already this epoxy has been loaded. You can see here, the epoxy has been loaded. This epoxy resin is now ready, and this epoxy resin now will be connected to a particular, what I can say, the device, and this device will be fixed to the entry ports. You can see it. Okay, these testing the whether the epoxy resin will properly eject through the that particular angle. Now he is fixing those gun to the entry ports. Now he is injecting those epoxy injection. You can see here how exactly this epoxy injection is done. Okay, so allow that epoxy injection to go inside that particular thing. Now again, see that bubble has been formed. Okay, the bubble has been closed. Till that you need to wait. Again you put that. Okay, see here the entire adhesive is going inside the particular crack. Okay, slowly it is going throughout the length of the crack. Okay, and later on you can remove that. You can see this is what a process. See, whatever that has been applied, those resin is started to flow throughout the length. So this is one particular formula, which we are going to use. One more method is there, which I am going to show you. Is a new technique or new method. Crack injection or crank. Okay, this is a kit. So something improved version I can say. See, this is a typically a shallow surface crack on the slab. Okay, so initially see how they are cleaning. Okay, they are removing all the dirts. So it is a huge crack. It is a huge crack. Okay, you can see the width. Okay, he is blowing the air. Okay, so that he can remove it. And this is a miracle bond, which that means it is a product name. Okay, that is an adhesive they are going to apply initially. Okay, so that it is firmly fixed, so that the injection, whatever the entry ports, okay, we can fix it properly. You can see here how there. Okay, this is what a wrong method. Instead of this, what I have been suggested here is you can put a tape. You can put a tape on the surface, okay, and you can properly, apply this bond. Okay, and another thing you need to keep in mind, whatever the bond you have been applying, okay, that bond should be firmly fixed to the old concrete. Okay. Next, you can see the entry port, which have been explained. The same entry port they are going to fix up at a particular distance, or a nipple I can say. Okay, so now they have been firmly fixed. Now, as I told, allow this particular bond to get cured, and as told, please wear this eyewear. Okay, next, prepare the epoxy resin. Prepare the epoxy. This is what epoxy resin. Okay. Okay. So now he is fixing those which I have been told. Okay, and now exactly we will be applying those epoxy adhesives. So this is what the technique they are going to use. So he is testing whether that epoxy will come out properly or not. Okay, so he is just testing. Okay, that is what epoxy resin. This is what epoxy polymer based resin, and this will be, this is a one more way they are connecting to the pipe, and they are fixing to the entry port, and later on they are going to, inject those epoxy to the prepared entry ports. So like this, they are going to do the epoxy injection to heal the cracks. Okay, you can see here, at one end he is injecting, at another end he is coming, means particularly this length is completely filled. Again, you will be filling this, till that, at other end this particular entry ports, whatever the adhesive that has been poured will come out. Okay, at that particular instance, I am going to stop. Okay, so like that they are going to, see now, they have been completely removing those and they are going to finish those slab and they are going to heal that crack on the slab. See, this is what I finished face. So like this, they are going to heal the cracks on the slab. So this is what a typical way of doing the epoxy injection. Hope the concept has been clear. Okay. Next is coming to the next topic, that is guniting and shotcreting. I think this topic you people have already been read. Okay. So once again I am going to repeat. Okay. Guniting means defined as mortar, that is mixture of sand, cement, all those things, conveyed through a hose and pneumatically projected at high velocity. This is very important. That means whatever the mortar, that is gunite, okay, whatever the concrete, that is shotcrete, okay, so that will be applied on the concrete surface or whatever the reinforcement that has been, okay, what I can say, prepared, okay, with a high pressure, So that is what guniting or shotcreting. Recently, this method has been further developed by introducing of small size coarse aggregate. That means when you want what I can say coarse aggregate content inside the concrete, okay, and why they are mentioned small size, because if you're going to use a bigger size coarse aggregate, we cannot what I can say, eject the concrete or whatever the pump the concrete with a high velocity. That's why they are going to reduce the size of the coarse aggregates. Okay. There is not much difference between guniting and shotcreting. Gunite was first used in early 1900 and this process is mostly used for pneumatical application of mortar of less thickness, whereas shotcrete is a recent development of similar principle of guniting for achieving greater thickness with. That's what. Guniting means mortar, shotcreting means with smaller size coarse aggregate. Okay. So there will be two processes, one is wet mix process, another one is dry mix process. Let us see what is that wet mix and dry mix. Dry mix means number of stages, that is a typical small plant is set up is shown, okay, which I am going to show you. This material is carried by compressed air through the delivery hose to a special nozzle. That means the mixture of sand, okay, the mixture of cement, all those things, okay, will be carried through the compressed air through the delivery hose or a pipe, okay, and then the nozzle is fitted inside with a perforated manifold through with water, okay, that means at one end will be fitted with a water, okay, those water and those dry mix will be poured at a time so that, okay, those mixture will be properly, okay, done with a high velocity. That's what. So those wet mortar is jetted from the nozzle at high velocity onto the surface to be gunited or shotcreted. Next, what is wet mix process? Wet mix process, that is the concrete is mixed with water as for ordinary concrete before conveying through the delivery pipe to the nozzle, at which the point is jetted by compressed air or onto the work in the same way as that of dry mix. That means the main difference between the dry mix and the wet mix process is, in the dry mix process, all the constituents of guniting and shotcreting are mixed and separately sent on the hose pipe, and the water will be sent on the separate and it will be sprayed on the concrete surface later by mixing. But in the wet mix process, all the constituents like cement, sand, aggregates, water will also be mixed and later on we are going to deliver through the hose pipe and will be done, the concreting will be done at the high velocity. So that is what the difference between dry mix process, and this is what a typical way you can see exactly they are going to do. See, this is what the dry mix process, okay, you can see, okay, the air compressor, okay, this shotcrete gun, okay, so this is what a reinforcing mat you are going to use, and this is a readily mixed pump he has been brought, that means truck, okay, that means all the mix they have been done, okay, that will be pumped to the concrete, and those concrete pump, okay, will be connected to the compressor and they are going to put the concrete. So this is what the way they are going to do the concreting. That is, one is dry mix process. The main difference is the water will be not, okay, water will be sent separately in the dry mix, but in the wet mix, all the constituents are mixed and later on, okay, all the materials will be sent. Okay, next, coming to the next techniques, it is not a repair technique actually. This is not actually a repair technique. It is one of the formwork, okay, which I am going to use. Okay, which one of the formwork I am going to use, okay, for a structural purpose. Okay, this is not a technique. So these are all the different techniques which have been discussed now. Okay, so this is one more separate topic, that is shoring and underpinning, okay, or underpinning. Okay, this particular technique you have been learnt in your building materials and construction course. So once again it will be repetition for you people, okay, so which I am going to explain. So till now I have been discussed the various techniques for repair. Hope the concept has been clear. So all these techniques will predominantly use depending upon the type of the damage. Is it clear? Okay, so we'll look into the next thing, that is shoring and underpinning. So what is meaning of shoring? Shoring means, first let us discuss shoring and later on we'll come to the underpinning. So shoring is generally used in construction to describe or to support a structure in order to prevent a collapse. That means it is a formwork provided, it is a temporary formwork provided, okay, to support the structure. That is what shoring. Shoring is used to support the beam and the floors in a building while a column or wall is removed. Okay, so in order to support a beam and floor, okay, while the column and wall is removed at that particular instance, so this shoring will be used as a temporary support structure. Okay, but in trenches, okay, in trenches, this plays a very important role. During excavation, shoring system provides safety for workers in a trench and speed excavation. In this case, shoring should not be confused with shielding. Okay, it is a very important thing when you go into dig the huge trenches. It is a very important thing and also a safety measure. Okay, while you are going to dig or excavate the soil, okay, and you are going to excavate the trenches, okay, those side, okay, the soil, okay, to avoid the landsliding or whatever the sliding, we are going to provide the vertical support. Okay, those vertical supports will act like a shoring. Okay, which I am going to show you now. Okay, shoring is designed to prevent collapse, where shielding is only designed to protect workers where collapse, that's what I have been told. So it will act like a protection for the workers also. Next, these are the different types of shorings: racking shores, hydraulic shoring and beam and plate shoring. The different types of supporting. Let me see what is that. Racking shores consists of one or more timber sloping, it is a timber structure, between the face of the structure to be supported and the ground. The most effective support to give racker meets the wall at an angle of 60 to 70 degree. That means inclined timber, okay, which I am going to provide at an angle of 60 to 70 degree. Next, hydraulic shoring. Hydraulic shoring is the use of hydraulic pistons that can be pumped out until they press up against the trench walls. They are typically combined with steel plate or plywood, either being 1 to 1/8 inch thick plywood, or specially heavy Finland form. That means this is a product name, okay, Finland form they are going to use. And also they are going to use a beam and plate technique. So this is a beam and plate, is a steel I-beams are driven into the ground and steel plates are slid in amongst them. A similar method that use wood plank, that means instead of steel structure you can go with wood plank. So this picture clearly explains you. So this is what a racking or inclined shores. So this is what a single racking timber. Okay, you can see this is what a structure and this is what a floor. You can see here this is what a wall plate. Okay, this is what a cleat. Okay, and this is a needle that has been attached, and this is what a racker, the inclined portion which have been explained. Okay, that is 60 to 70 degree. What is the support you are going to give to the vertical support? Okay, that is called racker. Okay, so this is what a typical view of racking shores. Okay. Next, this is what hydraulic shoring. Okay, they are going to use a hydraulic method. Okay, the plate and all are same. Typically it is same beam and plate technique only, but the formwork they are going to use is typically hydraulic methods. So that's why it is called hydraulic shoring. Okay, and preferably this, when you're going to dig the trench, because this is a small trench, okay, but then when you're going to dig a huge trench, especially for STP, sewage treatment plants, all those things, okay, when you're going to work inside the trench, it will be very dangerous for the workers, because there is a chance of landsliding or whatever the soil that has been removed. So in order to avoid those things, you can go with these techniques. Okay. Next, this is a typical, you can see the trench. So this is a huge trench they have been made. This is the surface level. Okay, you can see this is the ground level. Okay, the digged level. Okay, and you can see over there, okay, what is the depth they have been excavated, and this is what a beam and plate. Okay, they have been plate. Okay, and this is what a beam. This is what plate, and this is plates are connected by a beam. So this is what beam and plate shoring techniques. So like this various supporting or shoring techniques they are going to use in order to provide a support inside the or in the as a supporting structure. Okay, these are all temporary supporting structures. And this is one more way of providing, that is soil nailing. Okay, soil nailing is a technique in which the soil, that preferably the soil nailing will be done using the in order to avoid this, particularly the landslides, okay, particularly in the soil slopes, all those things they are going to provide this. So okay, I will repeat. Okay, the soil nailing is a technique in which the soil slope excavations or retaining walls are reinforced by the insertion of relatively slender elements, normally steel reinforcing bars. That means the soil will be reinforcing with a reinforcement bar. It is one of the reinforced earth structure. It is a reinforced earth structure. Okay, the bars are usually installed into the pre-drilled hole and then grouted into the place, or drilled and grouted simultaneously, because whatever the rods you are going to insert inside the holes, okay, so that particular thing need to be grouted. So those will be grouted using a cement grouts. So this is what the one of the way. So this is regarding your the shoring. Next, coming to the underpinning. Underpinning is the process of strengthening and stabilizing the foundation of existing building or other structure. That means strengthening. It is the one of the strengthening technique for foundation. Okay, this shoring, we have been discussed various measures, that is for concrete, that is the column jacketing, all those things, post tensioning, all those things. But how to strengthen the soil? For strengthening of the soil, we are going to use a underpinning method or underpinning techniques. Underpinning may be necessary for the following reason. The original foundation is simply not strong or not stable. Okay, at that particular instance, you require underpinning. The usage of the structure has changed. That means the building usage has been changed. The lie load has changed. Next, the properties of the soil supporting the foundation may be changed. The construction of nearby structure necessitates the excavation of soil supporting existing foundation. Okay, so for all these reasons they are going with underpinning. Okay, so this is one of the strengthening technique in order to strengthening the existing foundation. Okay, so that's what underpinning is accomplished by extending the foundation in depth or in the breadth. Okay, so it either rests on the stronger soil stratum or distribute the load. Okay, that's what the job does by underpinning or function of underpinning. An alternative to underpinning is the strengthening of the soil by introduction of a grout. Okay, so but this grout process is little bit expensive and elaborate. So these are the various methods of underpinning. Mass concrete underpinning method, that is pit method. Underpinning by cantilever needle beam method. Pier and beam underpinning method. Mini piled underpinning, piled method of underpinning, pre-test method. So these are the various methods. You can see this is the mass concrete underpinning method. It's a traditional method of underpinning as it is followed by centuries. Okay, the method involves extending the old foundation till it reaches the stable stratum. Okay, that is what the thing, extending the old foundation till it reaches the stable stratum. The soil below the existing foundation is excavated in a controlled manner through the stages or pins. When strata suitable is reached, that means hard strata is reached, the excavation is filled with concrete and kept for curing. That means it is strengthening to the existing foundation. This is the one method that is called mass concreting. That means providing concrete to the existing foundation. That is what called underpinning method. That is mass concrete underpinning method. Next is underpinning by cantilever needle beam method. That is, this is what cantilever beam needle method. You can see here. Okay. That is, the figure represents the arrangement of cantilever pit method of underpinning, which is an extension of pit method, that is earlier method. If the foundation has to be extended only to one side and the plan possesses a stronger interior column, this method can be used. That means you need to extend only on the one side, or when you want to strengthen only on the one side. Okay, at that particular instance, we are going with this. See, this is what an existing column or load or pedestal. Okay, and this is what an needle beam. Okay, and this is what a bearing plate, and this is what a jack. Okay, so this hydraulic jack is meant for to support this needle beam. Okay, and this is what a existing wall, okay, need to be strengthened. Okay, and you can see here, okay, they have been made a pit, okay, and they have been strengthened, all those things. Okay, this is the one method. Okay, and the advantages you can see: faster, one side access only, higher load carrying capability. Disadvantages: digging found uneconomical when existing foundation is deep. When you have a deep foundation, this method is not suitable. Okay. So next is pier and beam underpinning method. It is also termed as base and beam method, which was implemented after the Second World War. This method progressed because the mass concrete method could not work well for huge depth of foundation. That's what. So those two methods has been failed when the depth of foundation is more. Those two methods, that is first method, that is mass concrete method, and the next cantilever needle beam method has failed. At that particular instance, they have come up with this. It is found desirable for most of the ground condition. Here, the reinforced concrete beams are placed to transfer the load to the mass concrete bases or piers. You can show in the figure. Okay, so this is what a reinforced concrete piers. Okay, on whatever this particular thing, okay, will carry the load of a column, and that will be finally transferred to the soil. The size and the depth of the beam are based on the ground condition. That's what. That depends upon the SBC, the safe bearing capacity of the soil. Okay. Next is mini pile underpinning. Okay, this is one more method. This method is implemented where the load from the foundation have to be transferred to the strata located at a distance greater than 5 meters. It is a deep foundation. Okay, that means mini piles of diameter 150 to 300 mm. You already know that what is a pile. Okay, I think you have been studied in the basic geotechnical engineering. So the mini piles they are going to provide, okay, in order to carry the loads. So these are the various methods. Okay, and this is the typical pile. Okay, you are going to use. This is what a concrete pile. You already know that how they are going to do the pile concreting. So they are going to dig it. Okay, this is what a ground level. Okay, they are going to dig it through entire excavation. Especially this pile method is used for deep excavation. Okay, and throughout they are going to provide this metal casing, and later on they are going to pump the concrete to the entire depth of the foundation that has been excavated. Okay, and finally they are going to allow for a curing, and the prepared surface will be concrete pile, so that you can transfer the load. Okay, and this is what the way they are going to, okay, do the strengthening of soil. So these are the various methods. Okay, hope the concept has been clear. Okay, hope the concept has been clear. Okay, I think okay, I have been explained all the concepts of or techniques for repair and retrofitting techniques. Okay, and all these techniques are predominantly they are using in nowadays. Okay, in the civil engineering industries. Okay, so this, okay, by this almost I have completed all the course. Okay, so please look into this. Okay, and please practice these techniques, and please explore more about these techniques so that you can know more about all these techniques. Okay, did you get my point? Okay, a lot of innovations are happening day by day. Okay, so in order to overcome the various issues involved in the concrete structures. Is it clear? So this completes your module number 5. Hope the concepts has been clear. Thank you very much for this session.